Welcome to your arithmetic video number 2 for math tutor training. This one's all about decimals and fractions, but I'm going to be honest, it's mostly about fractions. First thing with decimals you got to remember is just the place values. That's going to help you to round. It's going to help you when you add and subtract. And multiply and divide decimals, you want to remember which place value is where. Alright, let's move on to fractions. Fractions. Before we talk about adding, subtracting, multiplying, and dividing fractions, let's look at just the definition of it. A lot of students will think, well, part of a whole, that's a fraction. Not quite a whole, it's just part of one. But then they come across something like 7/2, and their definition doesn't really hold true, because 7/2 is actually more than a whole, not part of one. But it's still a fraction. So let's talk about a different way to define it, by looking at its individual parts. So the bottom number, of course, is the denominator. Already definitions. It tells you how many equal pieces make one whole. So in this fraction, it's telling us that 2 pieces make one whole. Right? That is one whole. And we want to make sure that they're equal pieces, right? Not different sizes. And how many we have, we see in the numerator. It means we have 7/2. So a fraction, just putting that all together, oops, I need 2 more halves. Putting that all together in the definition, a fraction is a ratio that compares what we have of those equal pieces to how many equal pieces make one whole. So in this case, 2 halves make one whole. We have 7 of them. We could also write that as 1, 2, 3, and 1/2 left over. So if you think about this the fraction in this way, how many that we have and how many make one whole, it's a lot easier to think about adding, subtracting, multiplying, and dividing than just, it's part of something, part of one whole, I don't really know. So that's how come we define fraction in this specific way. Let's look at trying to add them together. First, let's consider things that are not fractions. So let's just say these 2 decimals, again, place value is really important. So the place values are lined up so we can add together the things that are the same size. Right? Whoops, oh, just kidding. That's a 6. 6.8. But let's say we're talking about some animals, right? 2 cats, 6 dogs, 6 cats. Altogether we have 8 cats. But if we had something like 2 dogs and 6 cats, we could maybe say we have 8 animals, right? Because they're different types of species, right? Different animals. Or maybe if you're thinking about that 90s show, Cat Dog from the 90s, that you can call them cat dogs maybe, let's see. But it doesn't really work. They're not the same unit. Kind of like trying to add 3 inches and 2 centimeters. Not quite the same thing. But the same idea holds true for fractions. 2/7, those are both like this big, maybe a 1/7, and 3/7. In total we have 5 the same size, 5/7. But if we have different denominators, a 1/6 is the different size than an 1/8. And so how do we compare those? It's a little bit tricky. We need some way to make them have something in common. We need to have the same number on the bottom of the fraction. Not 0, those are circles. 0 would be bad. We need like things. You're going to hear this principle a lot with addition and subtraction. We have to have like things. We have to have the same size units. And we get those with something called multiples. There are 3 methods of finding a common multiple. First, you can just multiply the 2 numbers together. So if we're trying to add 1/6 and 3/8, we can multiply the first one by 8, top and bottom. Make sure that we keep it the same fraction. So that becomes 8/48. And we can multiply the other one by 6, top and bottom. So we add those together, we get, for this one, 18/48. So altogether that's 26/48. You may notice that 48 is not the lowest common multiple. So that means I'm going to have to simplify. Divide by 2, top and bottom. Just like when we multiplied, we get over 24. Okay, so it doesn't always get you the lowest common multiple, but you don't always need that. You just multiply the two together. Here's another method. It's just list out multiples till you find the one they have in common. So multiples of 6. 6 times 1 is 6. 8 times 1 is 8. Nothing in common there. 6 times 2 is 12. 8 times 2 is 16. Nope. 6 times 3 is 18. Not yet. 8 times 3 is 24. 6 times 4, ta-da, is 24. There we go. So if we had instead multiplied by 1654 on top and bottom, we'd have 4 over 24. And the other one would become 9 over 24. We'd still get the same answer. All right, one more method for finding common multiples. This one's a little fancy. It's called using the prime factorization. Let's do 6 and 8 just so you can see that one. We'll get the same answer. So you're going to break down the number into primes. 2 times 3, can't go any farther than that. 8 we break down into 4 times 2, but the 4 can keep going. So we have 2 times 2 times 2. Okay, broke them down. Form the lowest common multiple with the largest amount of primes from each one. So let's see. 2 is prime, but on 8 there are actually 3 2s, so we're going to use the biggest number of 2s. And then 3 shows up right there. We don't need the 4 because remember the 4 is not a prime. So that if we multiply all those 4 numbers together, we get the lowest common multiple. Pretty cool. Here's why. Notice that we have the prime factorization of 8 there, and we have the prime factorization of 6 there. So both of them have to be present in order to make a common multiple, but it's the lowest because we didn't have that extra 2 there from the 6. And there we go. We're going to need bigger numbers after that. Just have the 8 and the 6. Alright, let's do one more example with this because we would have just done the same thing with the problem. But let's say we have 3 numbers, 12 and 21. And let's say 10. Okay, so we're going to break down these numbers into primes. So 4 times 3, that's going to be 2 times 2 times 3. 21 is 3 times 7. And 10 is 2 times 5. So I'm going to show you the lineup method now instead of just taking the largest amount of primes. If we line them up, so here's 12, 21, doesn't have any 2s, so we'll skip those. And 10 has 1, 2, and a 5. And I don't have a 3 or a 7, so here's my 5. So I'm going to line them up, and I'm going to take one of the primes from each column. 2, 1, 2 there, 1, 3, and 1, 7, and 1, 5. All right, we'll multiply those all together. 2 times 2 times 5 is 20, times 3 times 7 is 420. Is the lowest common multiple. So if I had 3 fractions with a 12, a 21, and a 10, I could multiply that. Alright, so these are the 3 methods that you can use to get that common denominator. Let's look at it if we have mixed numbers. So we'll do some more common denominators work here. So we have these 2. You want to worry about the common denominator only with the fraction part of the mixed number. So I'm going to keep the 1 and the 6 the same. I'm actually going to ignore those for now. Let's go ahead and do the multiply them method on this one since there's a 5 and a 4. So that's going to be this one by 4 and this one by 5. So 12 over 20, and we'll have 15 over 20, multiplying that by 5, and then add the numerators together, again still ignoring 1 and 6. 12 and 15 is 27, 1 and 6 is 7. You'll notice here we have an improper fraction, which usually is okay, but let's go ahead and change it to a mixed number. So 27 20ths is really 20 20ths and 7 more. And we have our 7 from over here. 20/20 is 1. So 7 plus 1 is 8. And 7 20s. And that's a regrouping thing, or borrowing, however you want to think about it, where you take out one whole amount. Let me show you what that looks like if we're subtracting. So, this one's already have a nice common denominator. Don't have to do anything there. And so we have 6 and 1/5. I'm going to write these vertically to give myself a little bit more room. Okay. If we look at the fraction parts, oh no, cannot take away 2/5 from 1/5 unless we're worrying about negatives, but it's a little easier to borrow instead of worrying about negatives. So I'm going to take away 1 just like I would if these were whole numbers, and I'm left with 5 here, 5 wholes. But when I add the 1 over, it's not just adding 1. What it is, it's adding 1 whole amount, so it's actually 5/5. So this becomes 5 and 6/5 minus 4 and 2/5. Okay, so subtract our fraction parts. That's 4/5. 5 minus 4 is 1. So when you borrow with these, it's important to remember that you're borrowing 1 whole. Whatever the denominator is, you can add that to the numerator when you borrow. Now real quick, I just want to flash back to the last video when we were talking about negatives. If I had reversed these, I would actually get the same answer, but the only thing that would change would be the sign, right? Because it would change which one was the bigger number. Let's look at a problem like that. So, who made this mess? Silly me. Okay. Here's the process we're going to walk through as we do this problem. So notice on our third problem here that the bigger one is a minus, it's a negative, and so we're going to end up with a negative answer. So to help me remember that, I'm going to write that bigger one on top. And I'm going to subtract them to figure out the value. And I'm just going to remind myself that it's going to be negative, so I'll write that right there. Then, just normal fraction stuff, get a common denominator, and then we might need to be regrouping. So let's get a common denominator. I'm going to multiply this one by 11, and this one by 3. So I have 52 and 22 33rds, 23 and 27. Oh, yeah, we're going to have to borrow 33rds. All right, remind myself that those are negative. So let's borrow 1 from here, which is really 33 33rds, so 1 whole. So we have 51 and 55 over 33. And we can subtract now. Subtract those and we get, that's step 4 is subtract. We get 28 over 33. 51 minus 23 is also 28. And remember, it should be negative from where we started. So step 5, keep the sign of the stronger one and see if you can simplify, which we can't. So that one is done. Alright, that is adding, subtracting, common denominators. Let's look real quick at multiplying and dividing with fractions. Good news! Guess what? Multiplying does not require like things. Here's an example. Have you ever heard of a foot-pound? Pretty exciting. It is a unit of work. So say you were placing some force of 2 pounds over the horizontal distance of 3 feet. Then you would be doing 6 foot-pounds, can't really write that, of work. We didn't have to change any units so that they matched like we had to do with cats and dogs. And so multiplication, because of how it works with groups, don't have to change the units. Pretty cool. That means when you multiply fractions, you just multiply them. You don't have to change any common denominators. You just multiply the numerators and multiply the denominators. And of course, you can simplify. We can divide by 3. So we get 7/15. All right, that's multiplication. Pretty simple. Division is a weirdo. Look at these. 6 divided by 2. Just whole numbers, that's 3, but we already know with fractions, 6 times 1/2, I'm going to get the same thing. So just like it's old pal subtraction, Division, sadly, is a myth. All it is multiplying by a reciprocal. Fancy math word for flip the fraction over. So here's how you divide. Here's our last process of the video. Keep the first fraction, right? That one doesn't need to flip, just like the 6 stayed the same. And change to multiplication. Flip that over. Ooh, a negative. All right. And then for the second fraction, follow our process from over here. So that's negative 21 over 16. Don't have to simplify. I could if I wanted to change it to a mixed number, but that is all the operations with fractions. Go ahead and watch the next video about percents.